Hello everyone, for my project I decided to refurbish the x-axis of my 3D printer with the part you see here. The current x-axis of my printer is pretty par for the course and uses linear rods and bearings. The disadvantage of this design is that it's hard to assemble. There's quite a few different parts. It has relatively low rigidity, which is an issue for a machine like this obviously, and it's not very aesthetically pleasing. Knowing these disadvantages, I went about the redesign process. I knew I wanted to replace those linear rods and bearings with a single linear rail, but I had to figure out how to mount it. So I went and decided to make a plate that could mount to the existing mounting points using the existing bolts. And I also wanted to keep it clean, and so I used as few parts as possible and settled on the idea of brazing 3 plates together and then anodizing it. So knowing what the part was going to look like in my head, I went to SolidWorks so I could design it to be manufactured. I drew up 2D sketches and then added something called lightning holes, which decrease weight and add some flair. And I knew that I was going to be anodizing this and machining it myself, so I choose aluminum as the material because it machines pretty easily and it anodizes really well. At this point I was ready to go ahead and get started on building this part. I took my CAD that I had built and brought it into a CAM software where I got it ready to be cut on my MP CNC router. Some of the settings can be seen here if you're interested. I went ahead and fixtured it down to my machine, and here's some of the cutting process. Here is the brazing process and some trial runs with the propane torch. You'll see that when the fluid kind of pools up, it's definitely not a good joint, and when it sinks into the corner, kind of like a weld, it is a very good joint. So I took that knowledge moving on to the actual part. I got them to kind of sink into the corner, but added a lot of extra material to make sure that it was strong. The final product was super strong. I cleaned up the outsides so they could be anodized, but left the inside for a little bit of aesthetic. After the brazing process is the anodizing process. I'll leave a lot of the detail in the video, but after the part is thoroughly cleaned, it is submerged into an acid-water mixture. Electrodes are attached and a current is passed through the part, which hardens the surface, etches it, and allows dye to more readily be accepted. Once the part is actually dyed, any anodizing failures you have show up super clearly because the part simply will not pick up color. In my case, I had a huge issue. The brazing rod sort of dissolved away and it prevented the rest of the part from anodizing except where connected to the positive anode. Doing this again, I would be using sulfuric acid instead of bisulfate, and I would rely only on the TIG welds when anodizing parts. Here is the finished product. Thanks for watching.